March 14. 1944. Rechlin Laerts Luftwaffe Test Center, 90 kilometers north of Berlin. Hauptmann Werner Baumbach's hands trembled slightly as he recorded observations in his flight log, not from fear, but from something far more unsettling: professional disbelief. The twin-engine fighter he had just landed, captured intact 3 weeks earlier near Foggia, Italy, had achieved speeds his instruments initially registered as malfunctioning, 420 miles per hour in level flight at 25,000 feet. The Lockheed P-38 Lightning wasn't just fast, it had rendered every assumption about twin-engine fighter design catastrophically obsolete. The skepticism had been absolute when the first intelligence reports arrived in late 1942. American engineers, the Reich Luftfahrt Ministerium analysts concluded, had made a fundamental tactical error. They had mounted two Allison V1710 engines, each generating 1,425 horsepower, onto a single airframe, creating what German fighter doctrine dismissed as a grotesque compromise. Twin engines meant double the weight, double the drag, double the mechanical complexity. Every Luftwaffe tactician knew that fighters required agility above all else. The legendary Messerschmitt Bf 109 weighed barely 5,900 pounds empty. Early estimates suggested the P-38 exceeded 12,000 pounds before ammunition and fuel. It will be a target, nothing more, Oberst Gustav Rodel had declared during a tactical briefing at Luftflotte 2 headquarters in December 1942. Rodel commanded Jagdgeschwader 27, one of the Luftwaffe's most decorated fighter wings, with 98 personal victories earned across 3 years of continuous combat in North Africa and the Mediterranean. His assessment carried weight. American pilots will learn what we learned in Spain: heavy fighters cannot survive against dedicated interceptors. The P-38 will perform adequately as a bomber-destroyer, perhaps, but in fighter-to-fighter combat, it represents no threat. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This confidence was not arrogance. It was the product of systematic analysis rooted in 6 years of combat experience across Poland, France, Britain, Russia, and North Africa. The Luftwaffe had tested and rejected twin-engine fighters repeatedly. The Messerschmitt Bf 110 Zerstörer had been designed specifically as a heavy fighter and had been systematically destroyed by lighter RAF Hurricanes and Spitfires during the Battle of Britain. Surviving Bf 110 units had been relegated to night fighter duties and ground attack missions, where their vulnerabilities were less exposed. The lessons seemed inarguable. Speed and firepower could not compensate for poor maneuverability in close combat. A twin-engine fighter was a contradiction in terms. Lieutenant Klaus Mietusch, a 22-year-old pilot assigned to Jagdgeschwader 77, operating from Sicily in early 1943, wrote to his family in Bremen with casual confidence about the American P-38 seconds beginning to appear over Mediterranean targets. "They are large and easy to see," his letter noted, dated January 28, 1943. "Our tactics remain sound. We climb to their altitude, engage from advantageous positions, and use our superior turning capability to position for killing shots. 3 were destroyed yesterday by our Staffel without loss to ourselves. The American pilots seem brave but inexperienced. Their aircraft, while impressively large, handles like the cargo planes it resembles." Mietusch's assessment reflected standard Luftwaffe tactical thinking in early 1943. The P-38 was fast in a straight line. Intelligence estimates suggested maximum speeds around 390 to 400 miles per hour, but this meant nothing if the aircraft could not maneuver effectively. Bf 109G variants could reach 385 miles per hour, while turning inside the American fighter's radius. Focke-Wulf Fock-W 190, with their exceptional roll rate and robust construction, could dictate engagement terms through superior low-altitude performance and devastating armament. Yet something was wrong. The loss statistics didn't match the tactical assumptions. By February 1943, Luftwaffe units in the Mediterranean theatre were reporting unexpectedly high combat losses against P-38 formations. On February 9th, during fierce air battles over the Kasserine Pass in Tunisia, Jagdgeschwader 53 lost 7 Bf 109 seconds in a single engagement against 12 P-38 seconds of the American 1st Fighter Group. German pilots reported being unable to close effectively with the American fighters, which maintained speed advantages that prevented traditional tail-chase attacks. On February 17th, Major Joachim Müncheberg, a decorated ace with 135 victories commanding 3 Jagdgeschwader 77, was shot down and killed near Tunisia by a P-38. The loss shocked the Luftwaffe fighter command. Müncheberg was among Germany's most experienced pilots, holder of the Knight's Cross with oak leaves and swords, veteran of combat operations across 4 theatres. His death at the hands of American pilots in their ungainly twin-engine fighters suggested something fundamentally misunderstood about the tactical equation. The breakthrough came on March 22, 1943, when Lieutenant Hermann Graf of Jagdgeschwader 52, though briefly attached to units in Tunisia for combat evaluation, filed an after-action report that deviated sharply from standard assessments. Graf, already recognized as one of the Luftwaffe's highest-scoring aces with over 200 victories primarily earned on the Eastern Front, brought analytical precision to his observations. The P-38 is not a heavy fighter in the conventional sense, Graf's report stated. It does not attempt to turn with our aircraft. Instead, American pilots exploit pure speed and energy management. They engage from high altitude, dive at extreme velocity to deliver a single high-deflection pass, then use their superior climb rate to disengage vertically before we can respond. Our standard defensive brake turns are completely ineffective. The P-38 pilot simply climbs away at full power, and our fighters lack the engine performance to follow into the thin air above 25,000 feet, where American pilots seem most comfortable operating. Graf's report included specific technical observations. The P-38's twin Allison engines, each equipped with mechanical superchargers optimized for high-altitude operation, maintained power output at altitudes where German fighters experienced significant performance degradation. The turbochargers on the Allison V1710 engines, Graf had clearly studied captured technical documents, allowed the P-38 to sustain cruise speeds above 350 miles per hour at 30,000 feet, an altitude where Bf 109Gs could barely exceed 320 miles per hour and struggled to maintain combat effectiveness. More troubling still, Graf noted that P-38 pilots demonstrated exceptional discipline. They refused to be drawn into turning fights at low altitude, where German fighters held advantages. American formations maintained strict altitude discipline, used coordinated tactics that emphasized mutual support, and exploited their aircraft's unique characteristics, rather than attempting to fight in ways that suited German preferences. We are not facing poorly trained pilots, flying inferior equipment, Graf concluded. We are facing a different tactical philosophy built around aircraft capabilities we do not fully understand. Until we can examine a P-38 thoroughly and test it against our own fighters under controlled conditions, we are fighting blind against an opponent who has solved problems we did not know existed. Reichsmarschall Hermann Göring, commander of the Luftwaffe, personally reviewed Graf's report in early April 1943. The assessment contradicted his public statements dismissing American aviation technology as inferior to German engineering. Yet the loss statistics were undeniable. Luftwaffe fighter units were being attrited at unsustainable rates wherever P-38 seconds appeared in significant numbers. Göring issued a directive on April 18, 1943. Acquire an intact P-38 Lightning for comprehensive technical and tactical evaluation at Rechlin, the Luftwaffe's primary test facility. The aircraft was to be examined thoroughly, then flown by Germany's most experienced test pilots to determine its actual capabilities and identify exploitable weaknesses. the opportunity arrived faster than expected. On April 3, 1943, Lieutenant Robert Wieland of the 94th Fighter Squadron, 1st Fighter Group, was escorting B-17 bombers returning from a raid on Palermo, Sicily. Combat had been intense throughout the mission. Wieland's P-38F had taken flak damage over the target. Shrapnel had punctured his left engine's coolant system. The Allison V-1710 began overheating rapidly as the coolant drained away. Standard procedure required shutting down the damaged engine and feathering its propeller to reduce drag, but Wieland delayed too long. The overheating engine seized completely at 18,000 feet, the propeller windmilling uselessly and creating enormous drag. Wieland struggled to maintain altitude on the remaining right engine, but the asymmetric thrust made the aircraft nearly uncontrollable. He attempted to reach Allied-controlled airspace, but the damaged P-38 was losing altitude at 800 feet per minute. At 6,000 feet, still 40 miles from friendly territory, Wieland made the agonizing decision to put down in the first suitable field he could find. He spotted a relatively flat area near Prizzi, Sicily, in German-held territory. Wieland executed an emergency landing with his landing gear retracted to avoid nosing over on rough terrain. The P-38F slid across the field, tearing off both underwing fuel tanks and causing substantial damage to the belly-mounted radio equipment, but the airframe and engines remained largely intact. German troops from the Hermann Göring Panzer Division reached the crash site within 30 minutes. Wieland, shaken but uninjured, was taken prisoner. The P-38F, serial number 42 to 12652, was immediately secured and transported under armed guard to a nearby Luftwaffe airfield at Trapani. Oberst Johannes Steinhoff, commanding Jagdgeschwader 77, personally inspected the captured fighter on April 5. Steinhoff, holder of the Knight's Cross with oak leaves and swords with 176 confirmed victories, examined the aircraft with intense professional interest. His report, filed directly to Luftwaffe High Command, was unequivocal. This aircraft must reach Rechlin immediately. We have been fighting an opponent we do not understand. This machine will provide answers we desperately need. The P-38F was partially disassembled, loaded onto transport aircraft, and flown to Germany in 3 separate shipments over 10 days. By April 28, 1943, the Lightning sat in Hangar 7 at Rechlin Lairs, surrounded by Luftwaffe engineers, intelligence officers, and some of Germany's most experienced test pilots. Hauptmann Werner Baumbach, assigned to lead the technical evaluation, approached the reassembled P-38F with systematic precision. Baumbach was 38 years old, an experienced bomber pilot who had transitioned to test flying after being wounded in combat over Britain in 1940. He held a doctorate in mechanical engineering from the Technical University of Berlin and had personally evaluated over 40 different aircraft types for the Luftwaffe. His initial walkthrough inspection, documented in a 47-page technical report dated May 2, 1943, revealed design philosophies radically different from German practice. The twin-boom configuration was immediately striking. Each boom housed an Allison V-1710 engine, its corresponding main landing gear, and the turbocharger installation. The central nacelle contained the pilot, all armament, the nose wheel, and most flight control systems. This layout provided exceptional structural efficiency. The booms acted as stressed members supporting the tailplane, while the engine mounts distributed weight optimally. More significantly, the configuration solved a problem German designers had never adequately addressed: how to mount heavy nose armament without creating severe center of gravity issues. The P-38's weapons, 1 Hispano-Suiza 20mm cannon and 4 Browning 50 caliber machine guns, were clustered in the nose with no synchronization required since no propeller passed through the firing line. All weapons converged their fire at a single point, typically harmonized at 300 yards, creating devastating concentration of firepower. Baumbach noted this arrangement provided substantial tactical advantages. German fighters mounted their weapons in wings and engine cowlings, requiring careful harmonization and accepting that bullets from different guns would converge effectively only at specific ranges. The P-38's nose-mounted armament delivered full firepower concentration at any range, and pilots did not need to calculate deflection for dispersed weapon locations. The cockpit was spacious compared to German single-engine fighters, with excellent visibility through large canopy panels. The pilot sat high in the central nacelle, with unobstructed views in almost all directions. The twin booms flanking the cockpit did create blind spots directly to the rear, but these were minimal compared to the restricted visibility in a Bf-109's cramped cockpit or the structural members that obstructed views in many German designs. But what captivated Baumbach's attention most intensely was the engine installation. Each Allison V1710F5 engine displaced 1,710 cubic inches across 12 cylinders arranged in a liquid-cooled V configuration. At rated power, each engine produced 1,425 horsepower at 3,000 revolutions per minute, 2,850 horsepower total for the airframe. This was extraordinary. A Bf-109 G6, by comparison, mounted a single Daimler-Benz DB, 605 producing 1,475 horsepower. The P-38 had nearly twice the power of Germany's primary fighter. The turbocharger system fascinated Baumbach. German fighters used mechanical superchargers driven directly by the engine crankshaft, consuming significant power to operate and providing optimal performance only at specific altitudes. The Allison's General Electric turbochargers recovered waste energy from exhaust gases, spinning turbine wheels at over 20,000 revolutions per minute to compress intake air without parasitic power drain. This system, Baumbach wrote in his technical assessment, allows the P-38 to maintain sea-level power output up to approximately 25,000 feet. Our Bf Noji experiences significant power degradation above 20 dos, 0 feet. The FU-190A, lacking any supercharging beyond its basic mechanical system, becomes nearly impotent above 24,000 feet. If American pilots exploit this altitude advantage systematically, our standard fighters cannot compete in the high-altitude combat zone, where strategic bomber escorts must operate. The fuel system revealed additional sophistication. The P-38F carried 410 gallons of fuel internally in self-sealing tanks, distributed throughout the central nacelle and wing center section. Two 75-gallon drop tanks could be mounted on underwing pylons, extending range dramatically. Total fuel capacity with external tanks reached 560 gallons, enough for missions lasting over 4 hours at combat power settings. Baumbach calculated combat radius assuming standard tactical procedures, climb to 25,000 feet at economical settings, cruise to target at 300 miles per hour, engage in combat at full power for 15 minutes, return at cruise settings with reserve. The numbers were staggering. Approximately 600 nautical miles combat radius with external tanks, easily sufficient to escort bombers from England to targets deep in Germany and return. German fighters struggled to achieve half this range. The Bf-109G carried only 88 gallons of fuel, internally, providing combat radius barely exceeding 300 nautical miles. External drop tanks helped, but German fighters still operated at severe range disadvantage compared to the P-38. The armament installation received exhaustive analysis. The 20mm Hispano-Suiza cannon, mounted centrally in the nose, fired explosive shells at approximately 600 rounds per minute. The magazine held 150 rounds, enough for 15 seconds of sustained firing, or 30 separate 1/2-second bursts. Each 20mm shell weighed approximately 4.5 ounces and contained high explosive with impact fusing, devastating against aircraft structures. The 4.50 caliber Browning M. 2 machine guns flanked the cannon, 2 mounted above and 2 below. Each gun fired at approximately 800 rounds per minute, with 500 rounds per gun, providing combined output of 3,200 rounds per minute, or over 53 rounds per second from the machine guns alone. Combined with the cannon, Total firepower output exceeded anything in the German inventory, except specialized bomber-destroyer variants carrying 30mm cannon. A 2-second burst from this aircraft, Baumbach calculated, would deliver approximately 20 rounds of 20mm explosive shells and 107 rounds of 50-caliber armor-piercing incendiary ammunition onto a target. This concentration would destroy any fighter and severely damage heavy bombers. The nose mounting ensures all this firepower hits the same point. It is brutally efficient. By mid-May 1943, the technical evaluation was complete. Now came the critical test. Actual flight evaluation by experienced Luftwaffe pilots to assess handling characteristics, performance, and tactical vulnerabilities. Hauptmann Baumbach would fly first. On May 18, 1943, with engineers and intelligence officers watching from Rechlin's control tower, Baumbach settled into the captured P-38F's cockpit for the first test flight. The twin Allison engines started smoothly, their distinctive sound immediately different from any German. Fighter II 12-cylinder engines running in perfect synchronization created a deep, powerful growl rather than the high-pitched scream of a Daimler-Benz or the rough rumble of a BMW radial. Baumbach advanced throttles carefully, testing control response during taxi. The nosewheel steering felt precise and responsive, far superior to the tailwheel configuration of German fighters, which required constant attention during ground operations to prevent ground loops. The P-38 tracked straight down Rechlin's runway without wandering, visibility over the nose was excellent, and the brakes responded smoothly. At the runway threshold, Baumbach performed his final checks, confirmed tower clearance, and smoothly advanced both throttles to take off power. What happened next would fundamentally alter every Luftwaffe assumption about American fighter design and reveal that German pilots had been fighting at a severe disadvantage they never fully understood. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The acceleration was immediate and violent. Both Allison engines, spinning their 3-blade Curtiss electric propellers at maximum takeoff RPM, drove the P-38F down Rechlin's main runway with authority that shocked Baumbach. He had flown nearly every German aircraft in the inventory, from the nimble Bf-109 to the powerful FW-190 to the massive Junkers Ju-88 twin-engine bomber. Nothing had prepared him for this. The airspeed indicator climbed rapidly, 60 miles per hour, 80, 100. At 120 miles per hour, Baumbach applied gentle back pressure on the control yoke. The P-38F rotated smoothly, the nosewheel lifting clear of the concrete. At 135 miles per hour, the main gear broke contact, and the Lightning was airborne, climbing at what Baumbach's instruments showed as 3,400 feet per minute at full power. His first notation in the flight test log, scrawled hastily while maintaining climb attitude, read, "Initial climb rate exceeds any single-engine fighter tested. Performance suggests power-to-weight ratio miscalculated in intelligence estimates." Baumbach leveled at 5,000 feet to assess handling characteristics at medium altitude. The control response was unlike anything in his experience. The P-38's ailerons, massive surfaces spanning the outer wing panels, provided roll rate that seemed impossible for an aircraft of this size and weight. Baumbach tested progressive aileron inputs. Gentle pressure produced smooth, coordinated rolls. Aggressive inputs generated roll rates approaching 90 degrees per second, faster than a Bf-109G. The elevator response was equally impressive. Pitch control felt precise and well harmonized, requiring moderate stick forces that provided clear feedback without excessive heaviness. The aircraft tracked accurately in climbs and descents without tendency to wander or require constant trim adjustments. But the rudder characteristics puzzled him initially. The twin vertical stabilizers required minimal rudder input during coordinated maneuvers. The aircraft flew as though it naturally remained in balanced flight, the twin boom configuration providing inherent directional stability that German single-engine fighters struggled to achieve. Baumbach climbed to 15,000 feet and began systematic performance testing. He set power to maximum continuous setting approximately 2,600 revolutions per minute at 44 inches of manifold pressure and stabilized in level flight. The airspeed indicator climbed steadily, 320 miles per hour, 340, 360. At 15,000 feet in level flight, the P-38F stabilized at 382 miles per hour indicated airspeed. This was significantly faster than intelligence estimates had projected. The Bf-109G6, Germany's primary fighter, achieved approximately 352 miles per hour at 15,000 feet. The captured P-38F was 30 miles per hour faster, nearly 10% speed advantage at this altitude. Baumbach continued climbing, monitoring engine instruments carefully. The Allison engines, operating through their turbocharger systems, showed no signs of power loss as altitude increased. At 20,000 feet, manifold pressure remained stable at 44 inches. Cylinder head temperatures stayed within normal ranges. The engines were performing exactly as their design intended, maintaining sea-level power output despite the thin air. At 25,000 feet, Baumbach leveled again and conducted another speed test. Maximum continuous power produced 398 miles per hour indicated airspeed. He advanced throttles to maximum war emergency power, full manifold pressure, at 3,000 revolutions per minute. The Allison engines responded instantly, their superchargers forcing additional air into the cylinders. The airspeed indicator climbed past 400, past 410, stabilizing finally at 417 miles per hour. Baumbach stared at his instruments, momentarily questioning their accuracy. He cross-referenced with his backup airspeed indicator, checked for instrument errors, and verified his altitude. Everything confirmed the same impossible conclusion. The P-38F was exceeding 415 miles per hour in level flight at 25,000 feet. At this altitude, the Bf-109G6 could barely achieve 340 miles per hour. The W-190A5 managed perhaps 355 miles per hour. The American fighter had a speed advantage exceeding 60 miles per hour at combat altitudes where German bombers operated and Allied escort fighters needed to fight. Tactical implications are severe, Baumbach recorded in his flight log. German fighters cannot catch this aircraft in level flight above 20,000 feet. Pursuit is impossible. Interception requires perfect positioning. If P-38 pilots maintain altitude discipline and refuse low-altitude combat, our fighters lack effective countermeasures. Baumbach continued to 30,000 feet, an altitude where German fighters struggled significantly. The Bf-109G experienced severe power degradation, its mechanical supercharger unable to maintain adequate manifold pressure. Pilots at this altitude fought constant battles with sluggish controls, reduced engine power, and diminished maneuverability. The P-38F, by contrast, felt nearly unchanged. The turbochargers continued supplying pressurized air to both engines. Power output remained strong. Control response stayed crisp and immediate. At 30,000 feet, maximum continuous power produced 391 miles per hour, only 7 miles per hour, slower than at 25,000 feet. The performance degradation with altitude was minimal compared to German fighters, which lost 30 to 40 miles per hour over the same altitude gain. Baumbach pushed higher still, climbing to 35,000 feet. Here, German fighters became nearly helpless engines gasping for air, controls mushy and unresponsive, pilots struggling with oxygen systems and extreme cold. The P-38F continued climbing smoothly. At 35,000 feet, Baumbach achieved 378 miles per hour in level flight. No German fighter could operate effectively at this altitude. The P-38 owned the stratosphere completely. Baumbach initiated dive tests from 35,000 feet, carefully following American operating procedures documented in the captured pilot's manual recovered from the aircraft. He rolled inverted to maintain visual contact with the ground, pulled the nose through to establish a 45-degree dive angle, and advanced both throttles to maximum power. The acceleration was breathtaking. The airspeed indicator climbed rapidly, 400 miles per hour, 450, 500. At 550 miles per hour, indicated airspeed, Baumbach felt compressibility effects, beginning the controls stiffening slightly, a gentle buffet developing through the airframe. He maintained the dive to 20,000 feet, reaching 565 miles per hour indicated before initiating recovery. The pullout required firm back pressure on the yoke but remained controllable throughout. The P-38F tracked smoothly through the recovery arc, G-forces building progressively to approximately 5.5 Gs at the bottom of the dive. Baumbach climbed back to 32,000 feet using accumulated kinetic energy, the zoom climb consuming less than 45 seconds. Diving speed exceeds any Luftwaffe fighter, Baumbach noted. The Bf-109 experiences severe compressibility and control difficulties above 460 miles per hour. The 490 handles better, but encounters structural limits near 500 miles per hour. This aircraft reaches 565 miles per hour with controllable handling throughout. In diving combat, German fighters cannot follow. In zoom climbs, German fighters cannot pursue. The tactical cycle is unbreakable. After 90 minutes of intensive testing, Baumbach returned to Rechlin and executed a landing approach. The P-38F handled beautifully during the landing sequence. The tricycle landing gear configuration eliminated the ground handling difficulties that plagued German tailwheel fighters. Forward visibility during the approach was excellent. The pilot sat high, with no engine blocking the view ahead. The aircraft touched down smoothly at 95 miles per hour and rolled out straight with minimal braking. Ground crews surrounded the Lightning immediately, engineers peppering Baumbach with questions before he had even shut down the engines. His preliminary verbal report, delivered while still sitting in the cockpit, was devastating in its implications. This aircraft is superior to any fighter in our inventory at altitudes above 20,000 feet, Baumbach stated flatly. Speed advantage ranges from 30 miles per hour at medium altitude to 60 miles per hour at 25,000 feet. Climb rate exceeds our fighters significantly. Dive performance is unmatched. Range is double our capability. If American pilots use these advantages correctly, maintaining altitude discipline and refusing disadvantageous engagements, our fighters cannot defeat them through superior tactics or pilot skill. The performance differential is too large. The formal technical report, completed over 3 days of additional testing, including instrument calibration flights and handling evaluations at various weight configurations, expanded these conclusions with devastating precision. Maximum speed comparisons showed the tactical problem clearly. At 15,000 feet, P-38F achieved 382 miles per hour versus Bf-109 G6 at 352 miles per hour, 30 miles per hour advantage. At 20,000 feet, P-38F achieved 405 miles per hour versus Bf-109 G6 at 348 miles per hour, 57 miles per hour advantage. At 25,000 feet, P-38F achieved 417 miles per hour versus Bf-109 G6 at 340 miles per hour, 77 miles per hour advantage. At 30,000 feet, P-38F achieved 391 miles per hour versus Bf-109 G6 at 311 miles per hour, 80 miles per hour advantage. The speed differential increased with altitude. At the heights where strategic bomber formations operated and where escort fighters necessarily engaged, the P-38 held overwhelming speed superiority that nullified German tactical advantages in other performance areas. Climb rate comparisons were equally troubling. From sea level to 20,000 feet, the P-38F required approximately 6.5 minutes compared to 7.8 minutes for the Bf-109 G6. But climbing from 20,000 feet to 30,000 feet, the critical altitude band for bomber escort operations, the P-38F required only 4.2 minutes, while the Bf-109 G6 struggled for 7.5 minutes. American fighters can climb to escort altitude, engage our interceptors, dive away if pressed, and zoom climb back to bomber escort altitude faster than our fighters can pursue, the technical evaluation concluded. This creates an asymmetric tactical environment where American fighters control engagement terms completely. They can attack when they choose and disengage at will. Our fighters must accept unfavorable combats or abandon interception attempts entirely. The evaluation also identified the P-38's vulnerabilities, though these offered limited tactical exploitation opportunities. The aircraft's large-size wingspan of 52 feet compared to 32 feet for the Bf-109 made it easier to spot visually at long range. The twin-boom configuration created a distinctive silhouette, instantly recognizable, eliminating any chance of misidentification that might provide tactical surprise. Maneuverability, while impressive for an aircraft of its size and weight, remained inferior to dedicated single-engine fighters in specific regimes. The P-38 could not sustain turning combat with a Bf-109 or FW-190 at altitudes below 15,000 feet. In tight horizontal turns at low altitude, German fighters could gradually gain angles and position for firing solutions. But, and Baumbach emphasized this point repeatedly, these vulnerabilities mattered only if P-38 pilots could be forced into low-altitude turning combat. Intelligence reports and pilot debriefings indicated American training doctrine specifically prohibited such engagements. P-38 pilots were trained to maintain altitude advantage, engage only from superior positions, and disengage vertically using their climb performance and speed advantages. The vulnerabilities we have identified, Baumbach wrote, are largely theoretical. They exist only in combat scenarios that well-trained American pilots will refuse to enter. We cannot exploit weaknesses our opponents decline to expose. Major Hans-Joachim Marseille, reading Baumbach's technical report at Luftwaffe Fighter Command Headquarters, understood immediately the strategic implications. Marseille, though famous primarily for his exploits against the RAF in North Africa, where he achieved 158 victories, had returned to Germany in late 1942 after being severely wounded. He now served in a staff position, analyzing tactical developments across all fronts. This explains our loss rates in the Mediterranean and over the Reich, Marseille observed during a commanders' conference on June 3, 1943. We attributed our difficulties to American numerical superiority and improved pilot training. But the problem is more fundamental. They have deployed an aircraft optimized for precisely the mission they need to accomplish high-altitude bomber escort, and they have trained their pilots in tactics that exploit its advantages while minimizing exposure to its weaknesses. This is not good fortune. This is systematic planning executed with discipline. Marseille requested additional test flights in the captured P-38F, specifically to evaluate tactical scenarios and develop countermeasures. His test program, conducted over 10 days in mid-June 1943, involved mock combat against German fighters flown by experienced Luftwaffe pilots. The results confirmed Baumbach's conclusions and revealed how completely the P-38 dominated when flown correctly. In the first scenario, Marseille flew the P-38F at 28,000 feet, while 4 Bf-109 G6 seconds attempted to intercept from below at 22,000 feet. The German fighters climbed at maximum power, attempting to reach the P-38's altitude before Marseille could attack mock bomber targets. Marseille maintained level flight at cruise power, monitoring the climbing Bf-109 seconds below. When they reached 25,000 feet, still 3,000 feet below his altitude, he rolled, inverted, pulled, threw into a steep dive, and accelerated toward the lead Bf-109 at closing speed, exceeding 600 miles per hour combined velocity. In actual combat, this would have been a brief firing pass, delivering concentrated cannon and machine gun fire into the target. Marseille simulated the attack by flying within 300 yards of the lead Bf-109, then pulled firmly back on the yoke and transitioned into a zoom climb. The P-38F climbed from 25,000 feet back to 30,000 feet in 38 seconds. The Bf 109 seconds, already at near maximum altitude and having burned significant fuel during their initial climb, could not follow. They attempted pursuit but lost ground continuously. By the time the Bf 109 seconds struggled back to 28,000 feet nearly 3 minutes later, Marseille was positioned at 31,000 feet, ready to repeat the attack cycle. The German fighters have no answer, Marseille reported. They cannot climb fast enough to reach the P-38 before being attacked. They cannot follow the P-38 through its dive and zoom cycle. They cannot catch the P-38 inches level flight if it simply flies away. The only option is to attack bomber formations quickly at lower altitudes and escape before P-38 escorts dive on us. But this reduces our firing time on bombers and exposes us to defensive fire. We are accepting unfavorable tactical compromises because the alternative is worse. The second scenario tested whether German fighters could force the P-38 into disadvantageous combat through ambush tactics. 4W 190A5 seconds positioned themselves at 30,000 feet, hiding in the sun, while Marseille flew the P-38F at 28,000 feet, simulating a bomber escort mission. The Tublo 190 seconds dove on the P-38 from their superior position, exactly the type of attack German pilots had successfully employed against countless Allied fighters. But Marseille, watching carefully and spotting the attackers early due to the P-38's excellent visibility, simply advanced both throttles to maximum power and initiated a shallow dive to build speed. The P-38F accelerated to 440 miles per hour within seconds. The FOW 190 seconds, starting their attack at 30,000 feet and diving to 28,000 feet, reached approximately 420 miles per hour. They could not close the gap. Marseille maintained his speed for 2 minutes, opening the distance to over 3 miles, then pulled up into a climbing turn that brought him back to 29,000 feet. The FOW 190 seconds, having burned fuel during their dive and acceleration, now faced the same problem as the Bf 109 seconds. They could not climb fast enough to catch the P-38 at altitude. Marseille repositioned above them within 3 minutes and could have counterattacked at his leisure. Even ambush tactics fail, Marseille's report stated. The P-38's speed advantage means it can simply run away from attacks, then use superior climb performance to regain altitude before our fighters can pursue effectively. Unless we can catch a P-38 pilot making fundamental tactical errors flying too low, becoming separated from his formation, running low on fuel, we cannot force combat on favorable terms. The third scenario was most telling. Marseille requested that German pilots fly the P-38F while he flew the Bf 109 G6, allowing him to experience the problem from the defensive perspective. Hauptmann Emil Clade, an experienced test pilot, flew the Lightning at 27,000 feet, while Marseille attempted interception from various positions. Approach from below. Marseille climbed at maximum power from 20,000 feet. Clade saw him coming from miles away due to the Bf 109's contrail at high altitude. When Marseille reached 26,000 feet, Clade simply increased speed to 380 miles per hour and flew straight away. Marseille's Bf 109, already near its performance ceiling, could manage only 345 miles per hour at this altitude. The gap widened steadily. After 5 minutes, Clade was 6 miles ahead, and Marseille had burned 40 gallons of fuel with nothing to show for it. Approach from same altitude. Marseille positioned at 27,000 feet, 1 mile behind the P-38. Clade maintained cruise power at 320 miles per hour. Marseille advanced to maximum continuous power, achieving 340 miles per hour, theoretically closing at 20 miles per hour. But the moment Clade noticed Marseille closing easily spotted against the sky at this altitude, he increased power to 380 miles per hour and pulled away. Marseille could not match this speed at altitude. Approach from above. Marseille positioned at 29,000 feet, directly above the P-38 at 27,000 feet. This was the only scenario offering attack opportunity. Marseille rolled inverted and dove, building speed to 410 miles per hour. He closed rapidly, simulated a firing pass at 500 yards range, and then faced the critical problem: recovery. Clade, the moment he saw Marseille diving, pushed both throttles to maximum power and initiated his own dive to build speed. By the time Marseille reached firing range and needed to pull out to avoid overshooting, Clade had accelerated to 480 miles per hour and was diving away at 30-degree angle. Marseille attempted to follow, but his Bf-109 encountered severe compressibility at 465 miles per hour. The controls locked up, the aircraft shook violently, and Marseille had to reduce throttle and shallow his dive to regain control. Meanwhile, Clade bottomed out his dive at 15,000 feet, with over 500 miles per hour on his airspeed indicator, then pulled into a zoom climb that carried him back to 25,000 feet in less than a minute. Marseille, recovering from compressibility effects at 18,000 feet, could only watch as the P-38 climbed away beyond reach. His fuel was now critically low from the maximum power climb and dive sequence. Clade could have circled at altitude indefinitely, waiting for Marseille's fuel exhaustion to force him to disengage. "I cannot win," Marseille admitted in his after-action report. "Even when I begin with altitude advantage, the one scenario where Bf-109 has any opportunity, the P-38 pilot can escape, through superior dive performance and zoom climb capability. If he maintains discipline and refuses to turn fight after I attack, I cannot achieve firing solution long enough to ensure kills. This is not a question of pilot skill, this is pure physics. The aircraft performance differential is too large." The final test scenario brought everything into devastating focus. 8 German pilots, including several aces with over 50 victories each, flew 4 Bf-109Gs and 4 FW-190, as against Marseille in the single P-38F. The scenario simulated a realistic bomber escort mission. Marseille was tasked with protecting an imaginary bomber formation at 25,000 feet, while the German fighters attempted to reach the bombers to make attack runs. Marseille flew at 28,000 feet, 3,000 feet above the simulated bomber altitude. The 8 German fighters approached from various angles and altitudes, attempting to coordinate their attacks to overwhelm the single escort fighter. Marseille defeated all 8 fighters without allowing any to reach attack position on the mock bombers. 2 Bf-109 seconds approached from head-on at 25,000 feet. Marseille dove directly at them at 480 miles per hour closing speed, simulated a head-on firing pass devastating in actual combat, with the P-38's concentrated nose armament, then pulled up into a zoom climb before the Bf-109 seconds could maneuver. He regained 30,000 feet while the German fighters turned and climbed, unable to follow. 2 for 190 seconds attempted to dive on him from 30,000 feet. Marseille saw them coming, accelerated to 420 miles per hour level flight, and simply flew out from under their attack. The TW-190 seconds dove past his previous position, unable to adjust their attack angle rapidly enough. Marseille then reversed, dove on the foe 190 seconds as they attempted to climb back to altitude, simulated firing passes on both, and zoom climbed back to 29,000 feet. 4 fighters attempted coordinated attack from multiple directions simultaneously. Marseille selected the most dangerous threat, a Bf-109, approaching from his blind spot, dove to attack that fighter specifically, broke up the formation, then used his speed to disengage before the remaining 3 fighters could coordinate response. He climbed back to altitude and the German fighters, now scattered and disorganized, could not re-establish effective attack positions before exhausting their fuel. The mock combat lasted 28 minutes. Marseille simulated 6 successful firing passes against different German fighters. Not one German fighter achieved position for a simulated firing solution against him. When the exercise concluded, all German fighters were critically low on fuel, while Marseille still had 45 minutes of fuel remaining. This demonstration, wrote General Major Adolf Galland, General of Fighters, after reviewing Marseille's reports, confirms our worst fears. We are operationally outmatched at altitude. American fighters have technological advantages we cannot currently counter. Unless we develop new aircraft with comparable high-altitude performance, or deploy weapons that negate the need to close to firing range, we cannot prevent bombers from destroying our industrial capacity. The war in the air is being lost. By July 1943, captured P-38 F testing at Rechlin layers had been observed by over 40 senior Luftwaffe commanders and experienced fighter pilots. Every observer reached the same conclusion. German fighters were at severe disadvantage in high-altitude combat, and no tactical innovation could overcome the performance differential. Desperate measures were proposed. Some commanders suggested abandoning high-altitude interception entirely and concentrating attacks against bombers during climb-out and landing approach when escort fighters were less effective. Others proposed developing specialized bomber-destroyer aircraft with heavy cannon armament, accepting that these aircraft would be vulnerable to escorts but might destroy enough bombers to make the losses acceptable. The most technically sophisticated response was accelerating development of jet-powered fighters. The Messerschmitt Me 262, already in testing, offered speed and climb performance that would render the P-38's advantages irrelevant. But jet engine technology remained unreliable in 1943, and mass production would not begin until 1944, too late to affect the strategic bombing campaign's most critical phase. Meanwhile, operational losses mounted. Through summer and autumn 1943, Luftwaffe fighter units reported increasing encounters with P-38 formations that refused to be drawn into disadvantageous combat. American pilots maintained strict altitude discipline, used their speed to dictate engagement terms, and protected bomber formations with devastating effectiveness. On August 17, 1943, during the disastrous Schweinfurt-Regensburg raids, where Luftwaffe fighters destroyed 60 B-17 bombers, losses would have been even higher, except for P-38 escort fighters that prevented German fighters from making repeated attacks. Of the 60 bombers lost, fewer than 15 were shot down, while P-38 escort was present. By October 1943, Luftwaffe intelligence estimated that P-38 units were achieving kill ratios exceeding 4-1 against German fighters in high-altitude combat, and those ratios improved to nearly 8-1 when examining only engagements where American pilots maintained altitude discipline and followed their tactical doctrine. The captured P-38F continued serving as a training tool at Rechlin, allowing Luftwaffe pilots to familiarize themselves with American capabilities and develop whatever limited counter-tactics remained available. But everyone who flew it reached the same conclusion. "We are not fighting pilot against pilot," one German ace observed after his test flight. "We are fighting physics against physics. And physics does not care about courage, skill, or determination." The Americans have built an aircraft optimized for the specific mission they need to accomplish, and they have trained their pilots to exploit its advantages systematically. Unless we can match their technology or fundamentally change the terms of engagement, we cannot win. The P-38 Lightning had revealed a truth German air commanders struggled to accept. Technological advantage, properly exploited through disciplined tactics, was more decisive than numerical superiority or individual pilot skill. The revelation came too late and at too high a cost. The air superiority battle over Germany was already being lost, bomber by bomber, factory by factory, with P-38 Lightnings diving from 30,000 feet at 420 miles per hour, a speed German fighters could only dream of matching. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.